Hello students, good time to all. I am Chandan Kumar Pradhan. Welcome to YouTube channel Chandan Physics. In this video, we are going to discuss Sackur Tetrode equation. Let's begin. Sackur Tetrode equation is the expression of entropy of an ideal gas, and that expression is taken by taking the gas molecules are indistinguishable within that of thermodynamic system. When we study the concept of Gibbs paradox, that is paradox in case of entropy, as entropy is an extensive property, so it is the property of addition. But when we take the entropy expression, that is classical entropy expression, to calculate the additive property of entropy, it indicates a paradox that is known as Gibbs paradox. But that Gibbs paradox can be easily removed by taking Sackur Tetrode equation, which is the expression of entropy of an ideal gas. By using this expression of entropy, we can remove Gibbs paradox. Here an important point: in case of Sackur Tetrode equation, we are dealing with the system, and that system have particles. These particles are indistinguishable within that of thermodynamic system. How we achieve Sackur Tetrode equation to solve Gibbs paradox? For this, we have to consider two systems with same gas, and the gas molecules will be indistinguishable. So, what happens when the gas molecules are indistinguishable within that of thermodynamic systems? If we consider n number of such molecules within that of system, then they can be distinguished in n factorial ways to arrive at correct result. As n number of molecules are arranged within themselves at n factorial ways, so the mathematical expression for thermodynamic probability now changed. We can divide n factorial to the expression of thermodynamic probability by using Maxwell-Boltzmann statistics. That is, from Maxwell-Boltzmann statistics, W thermodynamic probability is equal to n factorial, which is the total number of molecules within that of thermodynamic system, multiplier I from 1 to k gi to the power ni divided by ni factorial. That expression we have already known. But to achieve the correct result, we just divide n factorial in that expression. Dividing n factorial, we have W by n factorial is equal to multipliers I from 1 to k gi to the power ni divided by ni factorial. Now that thermodynamic probability expression can be used to calculate the entropy of an ideal gas, which is called Sackur Tetrode equation. That is the thermodynamic probability. Thermodynamic probability. Let's say W dash. We know that the expression for entropy S is equal to K log W, thermodynamic probability, that is W dash, or S is equal to K, in place of W dash we substitute its value, that is double by n factorials. Log W by n factorial. Let an equation 1. Now we have to calculate what will be the value of log W by n factorials. Now log W by n factorial, which is log W dash, is equal to, taking logarithm, so it will be changed to summation of that particular multipliers. So it is written as summation over I log A by B, log A minus log B, again log A to the power m is equal to m into log A. It's written as Ni log of Gi minus log Ni factorial. Is equal to summation over I Ni log Gi minus, to expand that factorial logarithm we use Sterling's approximation. According to Sterling's approximation, log Ni factorial is equal to Ni log Ni minus Ni, minus minus plus Ni. Again, from Maxwell-Boltzmann distribution law, the expression for Ni is known to us. First we expand it, that is summation over I Ni log Gi minus summation over I Ni log Ni plus summation over I Ni is equal to the modifications. Now I write it from Maxwell-Boltzmann distribution law, energy distribution law, Ni is equal to Gi e to the power minus alpha e to the power minus beta into Ui. we know it. In place of ni we substitute that value. First, summation over I ni log gi minus summation over I ni. Here in place of ni we substitute, so it is log as gi e to the power minus alpha e to the power minus beta into ui plus summation over ni, that is the total number of molecules, which is equal to n. Summation over I ni log gi, expanding the bracket summation terms, so it's minus summation over I ni log gi minus summation over I ni log e to the power minus alpha minus summation over I ni log e to the power minus beta ui plus n. That term cancelled out, is equal to log e to the power minus alpha, so it's minus alpha to this side, log e is equal to 1. The term is written as minus minus plus alpha summation over I ni, again log e to the power minus beta ui to that term, and log e is equal to 1, minus minus plus beta constant summation over I ni ui plus n ni ui, that is the total energy. Summation over ni, total number of molecules, alpha is alpha into n plus beta into u plus n. As you know, beta is equal to 1 by kt. Here we substitute as summation over I ni is equal to n, that is the total number of molecules, and summation over I ni ui is equal to u, that is the total amount of energy, and constant beta 1 by kt, and total energy u is equal to 3 by 2 nkt for an ideal gas. Now these values are put it. Alpha n plus beta 1 by kt u 3 by 2 nkt plus n. Here kt cancel out, is equal to alpha n plus 3 by 2 n plus n, which is equal to alpha n plus 3 by 2 n plus n, which is equal to 5 by 2 n. That is the expression for what? Log w dash is equal to alpha n plus 5 by 2 n. Look here, as we say, e to the power minus alpha is equal to a, e to the power minus alpha is equal to a. So alpha is equal to minus log a. Now in place of alpha we put it minus n into log a plus 5 by 2 n, which is equal to that is n log a to the power minus 1, there will be no such change, plus 5 by 2 n, which is equal to n log 1 by a plus 5 by 2 n. The expression for partition function z is equal to n by a. Therefore as 1 by a is equal to z by n is equal to n log that is z by n plus 5 by 2 n, that will be the expression for log w dash. Let equation number 2. Now we can put the value of log w dash in the entropy expression, which is written as s k log w dash. Therefore equation 1 becomes entropy S is equal to k log w dash, or S is equal to k in place of log w dash, that is n log z by n plus 5 by 2 n. n k is multiplied n k log z by n plus 5 by 2 n k. Now we can put the expression of partition function for an ideal gas. Z is equal to V by HQ 2 pi m kt to the power 3 by 2, that is the partition function for an ideal gas. That partition function value is now put it in that of expression. Therefore entropy S is equal to nk log, that is V by n HQ 2 pi m kt to the power 3 by 2 plus 5 by 2 nk, or entropy S is equal to nk log V by n. Now HQ within that bracket term, that is to the power 3 by 2. So it is written as 2 pi m kt divided by h square to the power 3 by 2. There will be no such change, plus 5 by 2 nk, which is the required expression for entropy, and that is called the Sackur Tetrode equation. This is the expression for an ideal expression for entropy, expression for entropy of an ideal monoatomic gas. This is called Sackur Tetrode equation. The expression for ideal monoatomic gas, it is called Sackur Tetrode equation. Now, by using that Sackur Tetrode equation, we can remove the Gibbs paradox. For removing Gibbs paradox, we have taken these two systems are now combined. We replacing n by 2n and v by 2v. So, the entropy of the combined system, the entropy of the combined system becomes SAB is equal to, in place of n, that is changed to 2n, k log, again v changes to 2v, n changes to 2n, 2 pi mkt divided by h square to the power 3 by 2 plus 5 by 2, again n changes to 2n k. From these two terms, taking 2 as common, that is written as nk log, here 2 to cancel out, that is v by n, 2 pi m kt divided by h square whole to the power 3 by 2 plus 5 by 2 nk. Which is equal to SAB, that is 2. This one is the entropy of an ideal gas, which is equal to the sum of entropy of the two systems, as we say SA plus SV. So it is satisfy the additive property. It is satisfy the additive property. So we can say the Gibbs paradox is now resolved by taking the entropy expression for Sackur Tetrode equation. The Gibbs paradox now resolved. and the entropy, which is an extensive property, now satisfy the additive nature. So, with the help of this video lecture, we understand the concept of Sackur Tetrode equation as a modification. N factorial is divided in the expression of thermodynamic probability, which is the entropy expression. S is equal to K log W. Log W dash is now expanded. These substitutions are made by taking Maxwell-Boltzmann distribution law. Then we come to finally the entropy expression of an ideal monoatomic gas, which is called the Sackur Tetrode equation, and using that Sackur Tetrode equation we can easily resolve the Gibbs paradox by taking one condition, n by 2n and v by 2v. Then the entropy show the additive property which resolve the Gibbs paradox. So, with this useful and informative notes, let me wind up the session. Thank you.